Go outside on a clear night. Hold out your hand to the sky. Stretch your thumb and pinky as far as they will go. That small, seemingly empty space between them. It is not empty at all. It is a patch of sky crowded with thousands of unseen star systems, each a potential home. But tonight we are looking for just one object in that darkness. An object so large that our entire solar system would be a speck of dust inside it. A mouth in space so wide, it takes light itself more than 2 weeks just to cross from one side to the other. This is the story of TON 618, the shadow that dwarfs worlds. So what is this thing we call TON 618? It is what astronomers call a quasar, a beacon of light from the deep past, when the universe was only a fraction of its current age. A quasar is not the black hole itself. It is the blindingly bright chaos around one. It happens when a supermassive black hole at the center of a galaxy is feeding, pulling in vast clouds of gas and dust at furious speeds. That material heats up, creating a disk of light so brilliant it can outshine all the billions of stars in its own galaxy combined. We do not see the dark heart, we see the brilliant cosmic storm it creates. And at the heart of that ancient glare sits a monster of almost inconceivable mass. The best current estimate, though it comes with large uncertainties, places it at around 66 billion times the mass of our own sun. It is one of the most massive black holes ever discovered, a true titan from an era when the universe itself was still young and wild. A mass like that creates a gravitational boundary, a point of no return that beggars belief. The diameter of TON 618's event horizon is calculated to be about 2,600 astronomical units. 1 astronomical unit is the distance from the Earth to the Sun. This single shadow in space is wide enough to stretch far beyond our planets, beyond the Kuiper belt of icy worlds, and out to the very edge of the Sun's inner comet cloud. Let's try to truly feel that scale. Neptune, our most distant major planet, orbits the Sun at about 30 astronomical units. The bubble of our Sun's influence, the heliosphere, extends out to about 120. TON 618's event horizon is more than 20 times wider than that entire solar bubble. Our whole corner of the galaxy, the home of every world we have ever known, would fit inside this single dark mouth with an astonishing amount of room to spare. Think about humanity's farthest reach into the cosmos, the Voyager 1 spacecraft. For more than 40 years, it has been traveling away from us, a lonely messenger in the interstellar dark. It is now more than 160 astronomical units from the Sun, farther than anything we have ever sent. And yet, if you were to place our solar system at the heart of TON 618, Voyager's entire decades-long journey would not even get it close to the edge. It would be a tiny craft, lost deep inside the black hole zone of no return, with an abyss of empty, silent darkness stretching for weeks of light travel in every direction. And that leads to the number that truly bends the mind. If you could send a beam of light from one edge of TON 618's event horizon to the other, how long would it take? Not seconds, not minutes. It would take light, the fastest thing in the universe, about 15 days to make the crossing. Sunlight reaches Earth in 8 minutes. For the same journey across this black hole's mouth, you would watch 15 sunrises and sunsets pass here on Earth. This isn't just big, it is a scale that redefines what a place can be. To understand how extreme this is, we have to compare it to other giants. In 2019, humanity saw its first direct image of a black hole's shadow, the one at the center of galaxy M87. That was a triumph, revealing a titan of about 6.5 billion solar masses. But TON 618's mass makes M87 look modest. It is roughly 10 times heavier. Picture 10 of those M87 shadows, those star system swallowing voids, arranged side by side. Now draw one, single, larger event horizon that encompasses all of them. That is the scale we are dealing with. And what about the black hole at the center of our own Milky Way, Sagittarius A star? It weighs in at about 4 million times the mass of our Sun. Next to tons 618.66 billion, our galaxy's heart is not just tiny, it is a statistical rounding error. It is a single grain of sand next to a mountain. So if it is so enormous, why can we not take a picture of its shadow, just like we did with M87? The answer is distance, an almost unimaginable distance. Ton 618 is so far away that its light has been traveling for over 10 billion years to reach us. At that range, even its colossal size shrinks in our sky to an impossibly small point. Its apparent size is around 1 microarcsecond, far smaller than the 20 microarcseconds the Event Horizon Telescope can resolve. It is a giant, but a giant seen from across the universe. This brings up a natural question. How do you weigh something you cannot see? From 10 billion light-years away? You watch the material falling into it. The light from the gas swirling around the black hole is stretched by its incredible speed. The faster that gas is moving, the wider its light signature is smeared out. It is like judging the power of a hidden whirlpool by how fast the water is churning at its edge. These are clever, indirect methods, and they carry those big uncertainties. But they are the only way we have to size up these distant monsters. Now, stand at the edge of this abyss in your mind. What would it feel like? The popular image of a black hole is a violent cosmic vacuum, tearing you to shreds. But for something as colossal as Ton 618, the reality at the boundary is far stranger. The gravitational forces are so immense, but spread over such a vast distance, that the tidal forces, the difference in pull between your head and your feet, would be almost unnoticeable as you cross the event horizon. There is no spaghettification here at the edge. There is no violent gate. It would be the quietest, most serene cliff in the universe. You would not feel a thing as you crossed. No wall, no flash, just a gentle, insistent, one-way drift into a darkness the size of a solar system. A place from which no message, no light, no echo of your existence could ever return to the universe you left behind. It is a quiet door, and it only opens one way. How does the universe build a monster like this, especially so early in its history? The current thinking is that it begins with a seed black hole, perhaps hundreds or thousands of times the mass of the Sun, born from the collapse of the very first stars. In the dense, gas-rich environment of the young cosmos, this seed finds an endless buffet. Torrents of primordial gas stream into the young galaxy, funneling directly down to the center. Then galaxies themselves collide and merge. Their central black holes spiral towards each other, eventually combining in a cataclysm that sends ripples through space-time and leaves behind a single, larger descendant. Over billions of years, this cycle of feeding and merging builds a behemoth. During its feeding frenzies, this central engine acts as a cosmic regulator. The quasar's intense radiation and powerful jets can blast gas out of the galaxy, halting star formation. At other times, its influence can trigger new waves of starbirth. Its gravitational domain, the region where it is the undisputed master, can stretch for over 1,000 light-years, shaping the very heart of the city of stars it inhabits. Let's take a moment here. If these journeys into the scale of the universe bring you a sense of calm and wonder, consider subscribing. We explore one quiet marvel at a time, trying to find our own place among them. Now let us step away from our own time entirely. Through a process called Hawking radiation, black holes do eventually evaporate. But for one this massive, the timescale is almost eternal. It will likely endure for a number of years, represented by a 1 followed by nearly 100 zeros. It will outlast the stars, the galaxies, and every constellation we have ever named. In the cold, dark, far future of the universe, these ultramassive black holes may be the very last landmarks that remain. Against that backdrop of unimaginable time, our entire human story is less than a spark. But in that spark, we have learned to measure the darkness. We have learned to weigh the unseen and chart the distances to the edge of the visible world. Our brief consciousness is the tool the universe uses to understand its own grandeur. The light is not just out there, it is also in the understanding. So we are left with this strange reality. An object whose mouth is so wide that light needs 2 weeks to cross it, yet so distant it remains a mystery. A place so vast our species' entire journey into space would be lost within its shadow. It is a humbling scale, a quiet reminder that the universe has no obligation to be small enough for us to understand easily. Our gift is simply to be here for a short while, able to look up and wonder.